Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2024, paper 1, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1. Work out 12 squared divided by a third times the root of 36. It's quite hideous to start with, but I think it just simplifies down quite easily, doesn't it? So 12 squared, let's take it term by term. 12 squared is 12 times 12 is 144, isn't it? And then that's divided by what we've got in the bracket, 1/3 of the root of 36. Well, 6 times 6 is 36, so the root of 36 is 6. Okay, that's looking a whole lot easier already. So then I've got 144 divided by, what's a third times 6? 3 goes in. Jesus, I hate this thing. 3 goes into 6 twice, doesn't it? So I can cancel that 3 into the 6, leave 2. And then 1 times 2 is 2. So I'm ending up with 144 divided by 2 then, isn't it? What's half of 144? That's going to be 72. 72. Question 2. Measure the shortest distance from the point P to the line. Give your answer in millimeters. Okay, so, well, the shortest distance is going to be the line that is at right angles to that line. So if we can find the line that's right angles to the one that we've got there, and that passes through the point P, that will be the shortest distance. And probably the easiest way to do that is if you've got a clear ruler, is just to align the beginning of each scale on both sides on the line and kind of line the edge of the ruler up with the point P. And then that way you can just kind of measure from that 0 up to the point P, and that comes out to be around about 32 millimeters. I'm going to write down 32 millimeters for that. Question 3. The vector -3, 7 translates A to B. Write down the vector that translates B back to A again. Okay. Column vectors usually have the form x over y like that. So this value here means -3 units in the direction of x, and this value here means 7 units in the direction of y. So let's say I make a note of the point A, it's here. To get from A to B, I would be going 3 units in the opposite direction of x, so like 1, 2, 3 in that direction, and then 7 units up, 1, 2, 3, 4, 5, 6, 7. So that would be my point up there, B. Okay, so I'd be going 3 to the left and I'd be going 7 up, and then that is my vector. Let me just draw that on. Now if I want to go from B to A, I'm going to go along that vector in the opposite direction. So rather than going 3 to the left, I need to go 3 to the right, don't I? And rather than going 7 up, I need to go 7 down. So my answer would be 3 to the right and -7 up. Okay, so that's going to be my opposite vector. I'm going in the opposite direction. So basically I'm just flipping the signs around, aren't I? If you want to go down the vector in the opposite direction, change the signs. Question 4. The attendance for a rugby match is 8,400 people to the nearest 100. Write down the minimum possible attendance. Okay, so if it's been rounded off to the nearest 100, if you imagine a number line with 8,400 marked on it and going up in hundreds, then the next number on that scale would be 8,500 and the one below it would be 8,300. Okay, so if we were rounding to 8,400 to the nearest 100, we would be rounding from halfway between or closer. So it's this range of values, isn't it? So if you're halfway between those numbers or closer to 8,400, you're going to round to 8,400. Okay, so what are the limits? What is halfway between? So the lower limit is going to be 8,350 and the upper limit is 8,450. So what is the minimum possible value? The minimum possible attendance is going to be that one, isn't it? The lower bound. Okay, so it's going to be 8,350. And then part B says write down the maximum possible attendance. Well, the maximum possible attendance is the upper bound then, isn't it? It's going to be that one there. So it's going to be 8,450. Well, except 8,450 would actually round up. And because this is made, people are made out of discrete things, aren't they? So, you know, you have one person, two people. You don't have 1.175 of a person. So in this case, if it is discrete data, you usually expect to come one down from the upper bound because technically 8,450 rounds up. Now, if it was a continuous number, I would just leave it as 8,450, but it isn't. It's discrete, so that's the reason why I'm actually going to come down one to 8,449. Question 5. A school year has 78 students. 28 wear glasses. A quarter of the students who wear glasses are left-handed. 30% of the students who do not wear glasses are left-handed. Given that the universal set is the students in the school year, and G is the G means wears glasses, and L is left-handed, complete the Venn diagram. Right, so we know 28 wear glasses, but that's no good. That's everybody in this circle here, and so we don't know which one are both wearing glasses and left-handed yet. We need to start really in the middle of this diagram. That's the best place to start. So the quarters of the students who wear glasses are left-handed. Okay, so that's helpful. So what is a quarter of 28? So 1/4 of 28. So 4s go into 28 7 times, don't they? So that's 7. 7 students who wear glasses are left-handed. So now we've got a number that we can actually put in. That means that number in the center there must be 7. Okay, and then because we know 28 wear glasses altogether, and we've already accounted for 7 of them, that means the other 21 must be in this part here. Okay, right, and then 30% of the students who do not wear glasses are left-handed. Okay, so how many students do not wear glasses? Well, there are 78 altogether and 28 wearing glasses. So if I take that away, that leaves 50 not wearing glasses. Okay, and so if there are 50 people who are not wearing glasses, what is 30% of that? What's 30% of 50? Well, 30% of 50 is 3/10 of it, isn't it? 3/10 of 50. So 10 goes into 55 times, and 3 times 5 is 15. So that's going to be 15 people who are left-handed and not wearing glasses. So I'm going to have 15 here. So the rest of that 50, so 50 minus 15, is going to be 35 people who are not wearing glasses and are not left-handed. Okay, so we've completed the diagram. That's good. Part B says a left-handed student is chosen at random. Work out the probability that the student wears glasses. Okay, so this is what we call conditional probability. We want to know the probability that a student wears glasses given that they are left-handed. Okay, so that's what conditional probability means. And that means we're not picking from everyone in the universal set here. that would not be conditional probability. Conditional probability means you're picking just from the people who are left-handed. So I can only pick from these people in this circle here. Okay, and so from that group of people, how many wear glasses? Well, it's going to be these ones in the middle, isn't it? They're the ones who wear glasses. So what's the probability of you picking one of those? Well, there are 7 of them out of a total of 15 plus 7. That's 22 altogether. So the probability of picking one of those is going to be 7 out of 22. Question 6. The table shows the number of workers at a company in different years. We've got 2015 through to 2022 here then. And I've got a time series graph is drawn to represent the data. The first 4 points have been plotted. Complete the graph. Okay, so we've plotted 29, 34, 42 and 52. So we've already plotted these 4 and we now need to plot the rest. We need to plot these other 4 here there. So we're going to start at 2019 at 62. So 2019 at 62. Now there are 5 little squares between 60 and 70. So each little square is going to be 10 divided by 5 or 2 units. So 62 is 1 little square above 60. And then 2020 goes with 70. That should be a nice easy one to plot. It's just on both big lines. 21 is at 76. So 76 is going to be 3 little squares above 70, isn't it? Okay, 2, 4, 6, yeah. And then finally 80, that should be another easy one to plot. Okay. Now for a time series, we just join up the lines with a straight line. Okay, individual lines. So a straight line from that point to that point, a straight line from that point to that point, and a straight line from that point to that point. Part B says estimate the number of workers in the company in 2023. Okay, now in order to do that, I'm going to draw on a trend line going up through my data. Okay, so now you can see that the points aren't exactly straight, but it's a bit like a line of best fit. You know, you have to kind of angle your line around as best you can to kind of show like a trend line. So I think it's going to probably continue in that sort of direction like that. Okay, so finding the general trend and then just extending my line then on a little bit. Okay, and then I can read off that point there where it crosses 2023. So where's 2023 going to be? 2023 is going to be on this one here, isn't it? So it's that point there that we need. So what's that? Right, so that comes out to be 80, what, 4 little squares up from 80, so it's going to be 88, isn't it, on that line there? So we're going to go for 88. Question 7, here is a cone, and we know that a curved surface area of a cone is pi r L, where r is the radius and L is the slant height. And Beth tries to work out the curved surface area in terms of pi, and she's written down pi times 5 times 12, which is 60 pi centimeters squared. What mistake has she made? Well, the curved surface area of the cone is pi r L, where r is the radius, in this case it's that distance there, and L is the slant height, it says here. Now the slant height is this one. Okay, that's the slant height. This one, the 12, that's what we call the perpendicular height. Okay, so that's the perpendicular height. The green one is the slant height. So she has used the perpendicular height when she's meant to use the slant height. So I would say that she should have used 13 and not 12. So I've written she should have used the slant height 13 and not the perpendicular height 12. Part B says Adam uses pi equals 3 to estimate the area of the base of the cone. Work out his estimate. Okay, so the base of the cone is just a circle. So area of the base is going to be pi r squared. Now we know that the radius is 5, so that's going to be 5 squared. And we're estimating pi to be 3. Now that's not a great estimate of pi, but that's what he's gone for. So that is 25 times 3, or 75 then is the answer, isn't it? 75. Beth uses 3.14, that's a better estimate, for the area of the base of the cone. Is best estimate more or less than Adam's estimate? Tick a box. Well, she's used a bigger version of pi, so yeah, your answer is going to be bigger. If you're times through by 3.14 rather than 3, you're going to get 0.14, lots of 25 extra on your answer, so it's going to be more. So I would say that 3.14 times 25 is greater than 3 times 25. Question 8. Solve 7x minus 22 equals 4x plus 29. Okay, so we've got a linear equation here, unknowns on both sides. So let's try and resolve that. I've got 7x and 4x here and here. So if I take the smaller one away from both sides, so take off 4x from both sides, then they'll cancel on that side. And it will leave me with 7x take away 4x, which is 3x. So I get 3x minus 22 is equal to 29. Next step, let's get rid of that 22 on the left-hand side by adding 22 to both sides. Again, that will cancel. And then that will leave me with 3x equals 29 plus 22. That's 51, isn't it? So 3x is 51. And then finally, divide both sides by 3. We'll cancel those. Leave me with x. And then 51 divided by 3, that's 17 then, isn't it? So x is 17. Question 9. In a house, the floor area of the living room is 26 square meters and the floor area of the kitchen is 16.4 square meters. Express the area of the living room as a fraction of the area of the kitchen. Give your answer is as a fraction in its simplest form. So we've got, I want to write this one as a fraction of this one. So if I'm writing one number as a fraction of the other, the number itself is the number at the top, it's the numerator, and what it's a fraction of is the number at the bottom. So I've got 26 over 16.4 here. Okay, so we can't really have fractions with decimal numbers in, can we? So how can we get rid of that decimal? Well, probably the easiest thing is just to multiply top and bottom by 10 to start with. Just get rid of the decimal and then look to cancel after that. So I've got 260 over 164. And now I want to see if I can cancel that down. So common factors of 260 and 164. And I think 4 must go into both of them, mustn't it? So dividing them both by 4, perhaps to start with. What's that? 4's into 260. Well, 4's into 26 go 6 times remainder 2. So that'd be like 6, and then 4's into 20 go 5. So that'd be like 65 over, and then 4's into 164. Well, 4's into 16 go 4 times, and 4's into 4 go once. So that's 65 over 41. Just dividing top and bottom by 4. Have we got any more common factors? 65 and 41. They don't divide by 3, do they? Not 5 either, not 7, not 9, not 11, not 13. So I don't think we're going to get these any more simple than they already are. I think it is going to be 65 over 41. Okay, so that's about as far as I can get. Question 10a. Represent minus 2 is less than x, which is less than 4 on the number line. Okay, now we can do this by drawing 2 circles at negative 2 and 4. I'm going to draw a circle here, and I'm going to draw a circle up here. Now these need to be open circles because the value themselves is not part of the range of possible answers. Okay, and then we're going to join them up with a straight line. So x can be any number between those 2 points, but it can't actually be the end points. That's why we don't fill them in. And then it says solve 5x plus 14 is greater than or equal to 11. Now these solve very similar to linear equations, inequalities, so I'm going to do it the same thing. I'm going to take 14 away from both sides, kind of simplify the left hand side, so they'll cancel, leaving me with 5y on the left. 5y is greater than or equal to 11. Take away 14, that's minus 3, and then dividing both sides by 5, then I'm going to get y is greater than or equal to minus 3/5. Now There's no reason for you to convert that into a decimal. You're not a computer. Fractions are your friends. Just leave it like that. Move on. Y is greater than or equal to minus 3/5. Question 11. Describe fully the single transformation that maps shape A to shape B. Okay. Now this is an enlargement. I can see that already because the shapes are saying change size. But notice the original, the object, is bigger than the image. So this enlargement has actually made my shape smaller. Now that's fine. That can happen. It happens when you're using a fractional scale factor. So that's something to bear in mind. Now what I'm doing is I'm joining matching points together on object and image. Now the reason I'm doing that is because there's always a straight line from center of enlargement through the object out to its image. So if you do this a few times, you should find that all your lines end up converging on one point, and that one point will be the center of enlargement. So by joining up these matching points on object and image, I will be finding the center of enlargement. Okay, so a slight problem with my pen lining up there, but hopefully you can see that the center of enlargement is this point here, isn't it? So this is my center of enlargement. Now, to describe a transformation of this type, an enlargement, I need to know three things. It tells you here number of marks, how many things you need to say in order to get it. Right, so to get all those 3 marks, the first thing I need to say is the type of transformation it is. It's an enlargement, so that is worth 1 mark by itself. And then the next thing would be to mention where the center is. So where is the center? The center is that point down there. It's 1 minus 7, isn't it? So it's centered at 1 minus 7. And then the last thing I need to mention is the scale factor. Now you'll notice that A is twice as big as B along each of its dimensions. Look, that side there is twice as big as that one. But remember, we're starting at A and we're going to B. So really, B is half the size of A rather than A being twice the size of B. So the scale factor here then is a scale factor of a half. So yeah, 1 mark for enlargement, 1 mark for the center, 1 mark for the scale factor. Okay, 3 marks achieved. Question 12. A sector has radius 12 centimeters and angle of 60. Work out the length of the arc. Give your answer in terms of pi. Right, the length of the arc length. Now, an arc length is part of the circumference of a circle, isn't it? Okay, so if we know what the circumference of the circle is and we work out what fraction of the circle we've got, we should get the arc length of the sector. Okay, so you know 2 formulas for circle. Cherry pie delicious, apple pies are 2. So they're the 2 formulas that we need for circles. Now this time we want this one, don't we? C equals pi d. The circumference of my circle is pi times its diameter. So I need pi times the diameter, but this is not a circle, it's a sector. So, and we want the arc length, isn't it? So arc length is going to be equal to, then what fraction of a circle is this sector? Well, the angle at the center is 60. So this is 60/360ths of my circle, isn't it? So in other words, it's a sixth. 60 over 360 is the same thing as a sixth. So that's a 6 times pi times the diameter. Well, the radius is 12. So double that up to get the diameter, because remember the diameter goes all the way through the circle and out the other side. So it's going to be have a diameter of 24, not 12. Okay, and we know that 6 goes into 24 4 times. So that's going to give me as my final answer of 4 pi for the length of the arc. Arc length is 4 pi. Question 13. ABCDE is a pentagon with AB equal to 7. BC is 6. AB and BC are perpendicular. AB and DC are equal and parallel. Area and pentagon equals 54 centimeters squared. The pentagon is exactly one line of symmetry. Okay, so what's this going to look like? I think I might sketch it first, because like, you know, whenever I've got like a nice piece of grid paper or graph paper, I don't want to mess it up. So it might be worth planning it out first. So I've got my line AB, which I know is 7. And then I know that AB and BC are perpendicular. So if this is AB, so I'm going to have a line going off at this direction, which is at right angles, and it's going to end at C. Okay, AB and DC are equal and parallel. So that means I'm going to have DC is going to be a parallel to AB. So it's going to be like a line like that, which is going to be equal in length and parallel. So that's going to be my side D up there, sorry. And then the area of the pentagon is 54. I'm struggling with that at the moment. Oh, BC is 6. I forgot that. That's 6. And then the pentagon is exactly one line of symmetry. So we've got 4 points, and if it's got a line of symmetry, the line of symmetry then is going to have to go through here. So the tip of my pentagon is going to have to lie somewhere on this line. So presumably it's going to be up here somewhere. Okay, so that's going to be my point E up here. Okay, now it needs to capture an area of 54. So already we've got this rectangle down here, which is 7 times 6. That's going to be 42. So that leaves the triangle part to have an area of 12. Now we know that the base of the triangle is 6. So how tall is that triangle going to have to be so it has an area of 12? Remember, the area of a triangle is half base times height. So you might be thinking it's just 6 times 2, but that would be too shallow. I think it's going to be 4, isn't it? Because 6 times 4 is 24, and then when you halve it, you get an area of 12. So that means that point there is going to be 4 units above D. Okay, so now I feel I'm ready. I can sketch this. I think I've got a pretty good idea of what's going on. So that's my 7 line. So I'm going to draw a 6 line going off in this direction. So what? 1, 2, 3, 4, 5, 6, and then 7 in this direction, because it's equal and parallel. And then E is going to be in the middle of those, and 4 squares up. It's going to be up there then, isn't it? Now I know it's tempting to get started on the squarey paper straight away, but often it's better just to plan it out first. You know, plan twice, draw once is the way to do these things. Okay, so yeah, just a little sketch at the side first. Get a plan, then you're not going to make a a big mess of your little bit of paper that you've been given to do the work. Question 14. 4 chocolate bars and 3 packets of mints cost £4.70, and 5 chocolate bars and 1 packet of mints cost £4.50. Work out the cost of the chocolate bar and the cost of the packet of mints. So this is a simultaneous linear equation here, but written in worded form. So we need to kind of translate this into a couple of equations and then solve them simultaneously. So I'm going to use 4c plus 3m to represent the 4 chocolate bars and the 3 packets of mints. And I know that costs £4.70. And I know that 5c plus m is equal to £4.50. Okay, so that's my equation 1 and my equation 2. Now, I'm going to solve these by elimination, and to do that I need to have the same number of one of the things. Now, if I take this second equation and I multiply it up by a factor of 3, then I'm going to get 15c and 3m, and then I can cancel them. Okay, so what I'm going to do is I'm going to take 3 lots of equation 2, and I'm going to subtract 1 lot of equation 1. So I'm going to write it the other way around. So taking equation 2 and tripling it up, that's 5 times 3 is 15. 15c plus 3m is equal to 3 lots of £4.50. £4.50, £9, £13.50, isn't it? Okay, and then underneath that, I'm going to do equation 1, which is 4c plus 3m is equal to 4.7. And then I can do a subtraction. Okay, so then 15c take away 4c is going to give me 11c. 3m take away 3m, well that cancels out. That was the whole point of doing this. I've eliminated m now. And then I've got £13.50 minus £4.70. So 50 minus 70, I'm going to have to borrow a pound and make that 80. And then 12 take away 4 is 8. So I'm left with £8.80. So 11 chocolate bars cost £8.80. So dividing both sides by 11 then a chocolate bar is going to be £8.80 divided by 11, which I believe is 80p. Isn't that right? So a chocolate bar costs 80 pence. And what about the packet of mints? So now to get the packet of mints, we can just go back to one of our original equations. I'm probably going to go to equation 2 because that's the simpler of the two, because we've just got the 1m there. So I'm going to substitute c equals 80 pence into equation 2 and then see what I get. So then 5c, which is going to be actually 5 lots of 80 pence plus m is equal to £4.50. So 5 lots of 80p is £4, isn't it? It's £4. So 4 plus m equals £4.50. So then mints then must be 50p then, mustn't they? Okay, so mints are 50p. Now you might want to check this by subbing both numbers quickly into the other equation that you didn't use. So I used equation 2 to find m. So subbing both numbers into equation 1 just as a quick check. So is 4 lots of 80 pence plus 3 lots of 50 pence, is that equal to £4.70? Kind of gone off the edge of the page there. Let's just come back in a little bit. Is that true? Well, 4 lots of 80p, what's that? £81.60, £3.20. Is £3.20 plus £1.50 equal to £4.70? Well, yes it is. Okay, so then that's just a quick check to make sure I got the answer right. And I'll know in the test then, rather than when the paper comes back, that I've got it right. Question 15a. Between which two consecutive integers does the square root of 210 lie? Okay, well, if you know your squares, you should know which two squares 210 lies between. So if you think about your squares, 12 12s are 144, 13 13s are 169, 14 14s, 14 squared is 196, and 15 squared I seem to remember is 225. If you don't remember these, you're just going to have to work them out, aren't you? Multiply your numbers until you know all the squares. So I can see that 210 then lies between 14 squared and 15 squared then, doesn't it? So which two consecutive integers does the square root of 210 lie? Must lie between 14 and 15. Part B says, here are two calculations A and B. Use approximation to show that the answer to A is less than the answer to B. Okay, so when we're approximating, we tend to round each number off to one significant figure. So A would become, rather than 1.92 to the power of 7, it's going to be 2 to the power of 7. And rather than being 6.9 cubed, it's going to be 7 cubed. Okay? So 2 to the 7, what's that? 2, 4, 8, 16, 32, 64, 128. So that's going to be 128 plus, and then 7 cubed, or 7 sevens of 49, and then 7 lots of 49. I think it's 343. So again, I remember my cubes up to 10 because it's quite handy for the non-count paper. If you didn't remember it, you're just going to have to work it out. So 128 and 343, so adding those together, 128 and 343, 128 plus 343, what's that, 1, carry 1, 6, 7, 471. So I've got 471. And then for the other side, I've got the cube root of horrible number. Well, I'm just going to round that one off to one significant figure as well. So that what is the cube root of 1 million times 5? So the cube root of 1 million. Now notice it's got 1, 2, 3, 4, 5, 6 zeros there. If you cube root it, you're going to end up with 2 zeros. If you think about it, 100 times 100 times 100 is a million. So it's going to be the cube root of a million is 100. And then 100 times 5 is 500. Okay, so I've worked out it's 471 and 500, and we can see that 471 is less than 500. Question 16. The table shows information about the ages of members of two clubs. So we've got the swimming club and the cycling club. Swim club, at median age of the members is 21.2 years and their interquartile range is 7.3. And the cycling club, their median age is 29.7, so slightly older. And their interquartile range is 4.6, so that's slightly narrower. Compare the average age and the consistency of the ages of the members of the two clubs. Okay, so the average is the median. Median is a type of average. Got 3 types of average: mean, median, and mode, that you need to know for GCSE. So yeah, median is a type of average. So if we want to compare their averages, then we need to compare these two numbers here. But we need to do it in context. You can't just say that 29 is bigger than 21. You have to kind of talk in context of the question. So this question is about clubs and their ages. So we need to mention those things in our reply. So we can say, on average, the swimming club members, how many M's have I done there? Swimming club members are younger. And I'm going to put in brackets 21.2 years than cycling club members. And they have an average of 29.7. So I like to put the numbers I'm actually referring to in brackets after. I just want to put years on the end of that. Okay, so on average, the swimming club members are younger, 21.2 years, than the cycling club members, 29.7 years. Okay, so I've talked about the clubs, I've talked about it's about the age, and I've said one is younger than the other. So you need to answer in context. And then the next one, consistency. Consistency is a question about variation. How varied is your data? And a measure of variation or dispersion is what we need to look at here. So interquartile range is our measure of dispersion, and that's going to tell us how consistent the data is. Now, because the swimming club has an interquartile range of 7.3 years and the cycling club has an interquartile range of 4.6 years, that means the middle half of the data for the cycling club is much more consistent than the middle half of the swimming club. And from that we can say that the cycling club is more consistent in age than the swimming club. So again, I'm gonna put that in context. I'm going to mention the values. So the ages of cycling club members are more consistent then. And I'm just going to put in brackets IQR 4.6 than the swimming club. And I'm just going to put in brackets IQR 7.3. Okay? Yeah, so that's just my top tips for answering those. Answer in context, mention the values. Question 17, rearrange y equals 3x plus 7 over x to make x a subject. Now this is a slightly trickier rearrangement because can you see I've got an x in 2 different places here in this equation. So we need to kind of recombine them at some point so I can make x equal to something. Okay, otherwise if I was just collecting that 1x, I'd still have x on the other sides. So bearing that in mind, the first thing I'm going to do is going to times both sides through by x. Okay, if I multiply through both sides by x, then on the right hand side you'll notice that these are going to cancel out, and on the left hand side I'm going to end up with xy is equal to, and then on the right I'm left with 3x plus 7. Denominator is gone because I multiplied it through by x. Okay, next step, collect all the things to do with x on one side. So I'm going to leave the xy where it is, and I'm going to bring over the 3x to this side as well, just by taking 3x away from both sides. So I'm going to end up with xy minus 3x is equal to 7. Now you can see I've got all my x's together on one side. So what I'm going to do to try and kind of bring them all into one kind of thing with an x in it, I'm going to factorize it out of those two terms. So put in x at the front of my bracket like that, and then x times what is xy, it's y, and then x times what is minus 3x, it's minus 3. So then by factorizing, I've kind of gone from having two terms with x in with just one occurrence of the value of x. And then just to finish it off, I'm going to divide both sides by y minus 3, and I'll end up with x equals 7 over y minus 3, and that's going to be my final answer. Okay, so this is a very standard straight up rearrangement technique for when you've got multiple versions of the letter that you're meant to be making the subject. Collect them all to one side, factorize it out of all the different terms so you've got one of them, and then rearrange for x. Question 18, a circle is center O and passes through 0, 6. Write down the equation of the circle. That's a quite straightforward question. Equations of circle center origin always have the exact same form. They are x squared plus y squared equals r squared, where r is the radius of your circle. Okay, so I've got a radius here of 6. So this is going to be x squared plus y squared equals 6 squared. You don't even have to square out the 6. You can just leave it like that. That is all fine. Question 19. A, B, and C are numbers. Here is the information about B and C. B is 7/4 of A, and C is A increased by 150%. Ooh, that's not very nicely put. Work out C is a fraction of B. C is a fraction of B. So let's just make this a little bit more mathematical and take the wordy bits out. So B is 7/4 of A. That means that in math speak, that is B equals 7A over 4, isn't it? Okay, B is 7A over 4. And then C is A increased by 150%. So C is A increased by 150%. So it's going to be A times by, well, what's the multiplier going to be? If you increase something by 150%, you start with 100%, you add on 150%, that's 250%. So I'd need to multiply this through by 2.5 then, wouldn't I? So C then is going to be 2.5A. Okay? So now we know what B is in terms of A, we know what C is in terms of A. I think we can now write C as a fraction of B. And a bit like earlier, C as a fraction of B means C is the numerator and B is the denominator. So we're going to get 2.5A, we're going to get the C on the top, and we're going to get over, well, it's going to be 7A over 4, isn't it, as a fraction on the bottom there. Okay, so I don't really like fractions with 3 levels like that. Probably better to rewrite that, because we're dividing something by a fraction. Perhaps it's better to KCF, keep, change, flip. So I'm going to keep the 2.5A, I'm going to change that divide into a times, and I'm going to flip the fraction over. So it's going to be 4 over 7A like that. Okay? So then, can I tidy that up? 2.5A times 4, well, double and double it again, 2.5. 2.5 doubled is 5, doubled again is 10, so that's 10A. Isn't that 10A over 7A? and then those cancel because a divided by a is zippity zip, and that leaves just 10/7 then, isn't it? So that's my final answer, 10/7. 20. Oh, this looks fun. 5x cubed plus ax squared plus bx plus c is identical to kx cubed plus 2 minus k lots of x squared plus a squared minus 1 lots of x plus b over 2. All what you need to do is work out the values of a, b and c. Now this is an identity. You can tell it's an identity because of these 3 stripes in the middle, or not 2. Okay, and when you've got an identity, what you must never do is move things over it. Okay, what this is saying is the left hand side is exactly the same as the right hand side. You do not want to complicate things by moving things from one side to the other. You tend to work on identities one side at a time, or you compare one side with the other side. Now in this case we want to compare bits of the left hand side with bits of the right hand side, because if these are identical, they're identical in every way and every part. So we can say that if they're identical in every way, then the term in x cubed has got a 5 in it on the left hand side. That's going to have to be identical to the term in x cubed on the right hand side. In other words, I can tell from just looking at this that 5 is equal to k. We call this comparing coefficients actually, so to write this down properly, I'd say comparing coefficients of x cubed to start with. I know that 5 is equal to k. Okay, so I'm looking at the coefficients of x cubed to start with, and that's 5 is equal to k. Now if I was going to do the same thing with the x squared terms, what's that then? So a is equal to 2 minus k. A is equal to 2 minus k. Now we know what k is, so we know that a then is equal to 2 minus 5. It's going to be minus 3 then, isn't it? So now I know the value of a already. Okay, now let's carry on. Let's have a look at the next coefficient. So I've got b and a squared minus 1 up here then. So these two things must be the same when I'm comparing the coefficients of x. So I know that b is equal to a squared minus 1. Now I already know that a is minus 3. Square it, I'm going to get 9. Take away 1, I'm going to get 8. So I know then that b is equal to 8. And then finally comparing the constants. What are the constants then? So the constants are the numbers on the end. Now it might be written as a letter here, but it's actually the constant on the end because it hasn't got an x attached to it. So that's the constant on the end, and that's the constant on the other end. Okay, so from that I can tell that c must be identical to b over 2. Now I know b is 8 and b over 2 is 4, so c must be 4. Okay, so we worked out the values of a, b and c. A is minus 3, b is 8, c is 4. Easy squeezy. Just highlighting it up like that. There we go. That's where I got them all from. Question 21. Prove algebraically that 1.018 with a dot on the 1 and the dot on the 8 is equal to 56 over 55. Now, you are proving, so you are not to use this value. You're proving it is this value. So this value is off limits. Okay? Just pretend it's not there for now. Gone. Okay? I want to find it. I don't want to be using it. When you're doing a proof, don't use both sides of the proof. You need to start with one and make it look like the other. So I'll just obliterate what it is for now. I'll come back and just look at it later. So I've got 1.018 with a dot on the 1 and a dot on the 8, which is a recurring decimal, and I want to show that it's some sort of fraction, what the fraction is equal to. So I'm going to say let x be my recurring decimal, which is 1.018181818 and so on. Now when you're writing out recurring decimals like that, you really need to do these little dots at the end. You can't just stop at what your 181818 and then expect people to know you still mean it's a recurring decimal. So you either write with the dots like that, or you put some little dots on the end there. Okay, otherwise you may lose marks on these sorts of questions. Now, because this is recurring over 2 digits, it's like 2 digits recurring, the 1 and the 8 and the 1 and the 8 and 1 and the 8. We need to multiply through by 100 in this case and find 100x. Okay, now the reason for that is all my digits shift over 2 digits. So I'm going to get 101 at the start, 0.8, and then 18, 18, 18, 18 after that. Okay? And then if I then subtract one from the other, little algebraic trick here, then you can see that that 8 cancels that 8. Oops. That cancels with that, that cancels with that, that cancels with that. In fact, all of that cancels with all of that, doesn't it? All the 18, 18, 18, 18 all cancel each other out. And we're just left with 101.8 minus 1. And that gives me 100.8. On the other side, I've got 100x minus x. That's going to leave me with 99x. Okay? Getting warmer. So now, what do we do now? We need to tie this up then. So we're going to make x a subject. So x is equal to 100.8 over 99. Now that, I can't remember now what was under that thing, but it wasn't 100.8 over 99. So I guess we can now simplify this in some way. We certainly shouldn't leave it with a decimal on the top there. So can we get rid of the decimal somehow? Well, I suppose we could just times every top and bottom through by 10 to start with, 1008 over 990, and then look for divisors. What can I divide this by? It's so big. I don't know. What goes into 990 that also goes into 1008? Well, 4 definitely goes into the top. Does 4 go into the bottom? Don't think it does. 2 certainly does. Well, let's halve it first. So halving that would be 504 on the top, and half of 990 would be 495. Okay, I think I'm allowed to have a little peek now underneath what was under here now. So we're aiming for 56 over 55. Okay, so we're not too far away. So here we times by 10, here we divided by 2. Now, how are we going to get from 504 down to 56? 56 goes into 504. How many times? Well, if you look, 5 plus 0 plus 4 adds up to 9, and 4 plus 9 plus 5 adds up to 18. They're both divisible by 9, so that means my number divides by 9. So dividing top and bottom by 9, I think, then gives me the answers I'm looking for. So 9s into 504 go 56 times, woohoo! And 9s into 495 go 55 times. So we've done it, okay? We only had a little bit of a peek at the end. But yeah, like I say, don't use both sides of a proof statement. You need to take one side and make it look like the other. Start with the left side, make it look like the right side. Question 22. A, B, and C are points in a circle center O. AP and BP are tangents to the circle. Work out the size of angle X. Now, there are various circle theorems already visible in this diagram that will help us, but I think by adding some extra lines on here, we should get a little bit more clarity, because I noticed we've got O marked in the center, but we've not got the radiuses added onto the diagram, have we? So I'm going to add those in, because I think they will add to the picture and make the solving of this question easier. So what I'm going to do is I'm just going to add an extra line in here, because I know there's a rule about radii meeting tangents at 90 degrees. Okay, there and there. I think that might be helpful. And there and there. So they're both 90 degrees. Now, I don't overly focus on the thing I want to find. What am I even want to find here? I'm trying to find X. I kind of think about what I've got and then what I can find from it. So I'm going to start, now I've added those 2 extra lines in, I've actually got a kite in the middle here, haven't I? This is a kite. And I know things about kites. I know they're quadrilaterals. I think I only really need to know that they sum to 360. I think that's the only fact I need to know about this kite. So in kite PBOA, I know that angles sum to 360 degrees in a quadrilateral, don't they? So I know my 24 degrees at P plus my 90 degrees at B plus my 90 degrees at A plus my angle AOB, that should be equal to 360 degrees. So adding the three other angles together, 90 and 90 make 180 plus 24 is 204. So take that away from 360. That means angle AOB then is going to be 360 minus 204, which is 156. Okay, and that's that angle there then, isn't it? 156. And then I'm going to use this shape here, this arrowhead, for next trick. Okay, now this is an angle subtended at the center and an angle subtended at the circumference, isn't it? And there's a circle theorem for that, and it says the angle at the center is twice the angle at the circumference. So then C, my angle X, is going to be a half of my angle AOB then, isn't it? So it's going to be a half of 156 and a half of 156. What's that? 78 degrees. Yeah, so that's that. Angle X is 78. Question 23a. The first three terms of a geometric progression are the root of 5 over 2, 5 over 4, and 5 root 5 over 8. Work out the next term. Okay, so this is a geometric progression, and geometric progressions mean that they have a common ratio between your two values. So there is something that I can times these by from one to the next. Now, in a geometric progression, we say the first term, if the first term is A, then the second term is A times R, what that common ratio is. And then the third term is going to be AR squared. And then so the fourth term is AR cubed. Okay, so then if we take any two consecutive terms, like if I take U2 and I divide it by U1, I'm going to get AR over A, and then that's going to cancel out and leave me with what the common ratio is. Okay, so if I do that with the numbers that I've got, then I've got the second term, 5/4, and I want to divide that by root 5 over 2. Now again, I had this thing earlier, I was dividing through by a fraction, so using keep, change, flip, I'm going to take that second fraction, I'm going to keep the first fraction, I'm going to change the divide into a times, and I'm going to flip the second fraction over. So I'm going to get 5 times 2 over 4 times root 5. Can I cancel anything? Just cancel those two first. It's going to give me 1 and 2. So I'm going to end up with 5 over 2 root 5. Okay, as my common ratio. Now I don't really like roots on the bottom, so I can just rationalize that by multiplying top and bottom by root 5. So that will give me 5 root 5 over 2 times root 5 times root 5. Root 5 times root 5 is 5 times 2 is 10. And then I can cancel that 5 and that 10. And that's going to give me root 5 over 2 then as my value of R. So the common ratio then is going to be, so we know now that R is going to be root 5 over 2. So then what is the next term? We want U4 then, don't we? We want to find U4. So I can find U4 by multiplying U3 by R. So U4 equals U3, the third term, times R, the common ratio. So it's going to be 5 root 5 over 8 times root 5 over 2. Okay? So just tidying that up. Top times top. 5 times root 5 times root 5. Well, root 5 times root 5 is 5. Times 5 is 25. That's going to be 25. And on the bottom, I've got 8 times 2, which is 16. 25 over 16, does that cancel down? I don't think it does. I think that's it, 25 over 16. And then part B says the nth term of a sequence is 2 plus root 3 to the power of n. show that the third term is 26 plus 15 lots of root 3. I need a bit more space for this. So we want the third term. We want u3. So what's u3? Well, u3, for u3, n is equal to 3, isn't it? So it's going to be 2 plus root 3 to the power of 3 then. In other words, we want to multiply out these brackets. 2 plus root 3 times 2 plus root 3 times 2 plus root 3. Yeah, I did need some space, didn't I? So just doing some FOIL on the second bracket and the third bracket. What have I got? Well, I've got 2 plus root 3 because I'm leaving the front one alone to start with. 2 times 2 is 4. Root 3 times 2 is 2 root 3. 2 times root 3 is another 2 root 3. So altogether that is 4 root 3. And then root 3 times root 3 is 3. So that gives me that. So just tidying that up before I then multiply out the second set of brackets. So 4 plus 3 is 7. So I get 7 plus 4 root 3 in the second bracket like that. And then we just do FOIL again. So I'm going to do 2 times 7, which is 14. I've got 2 times 4 root 3, which is 8 root 3. I've got root 3 times 7, which is 7 root 3. And then I've got root 3 times 4 root 3. Well, root 3 times root 3 is 3, and 3 times 4 is 12. So that's going to give me 12. Okay, so then tidying that up, the 14 plus the 12 is going to give me 26, and the 8 root 3 plus the 7 root 3 is going to be 15 root 3. Question 24a. 9k plus 7 and 2k squared plus 3 are consecutive integers. 9k plus 7 is the smaller integer. Work out the value of the next consecutive integer. Well, imagine you had two numbers. If I had like two consecutive numbers like 3 and 4, if I take one away from the other, what am I going to get? I'm going to get 1, aren't I? Because if they're consecutive, it means they're next to each other. So 4 subtract 3 is going to give me 1, isn't it? Because they're consecutive. And the same is going to be true from these rather hideous looking algebraic values. If I take one away from the other, I'm going to get 1. Okay, so if I let u1 be 9k plus 7 and u2 be equal to 2k squared plus 3, then I know that u2 minus u1 is going to be 1. If I take one away from the other, I'm going to have to get 1, aren't I? In other words, u2, 2k squared plus 3 minus 9k plus 7 is equal to 1. I think I can form a quadratic equation in k here, which hopefully I can then go on to solve. Okay, so let's just bring everything over to one side and simplify. So I've got 2k squared as my term in k squared. I've got minus 9k, and then my numbery part, I've got 3, take away 7, which is minus 4, bring the other one over, is minus 5. So I end up with 2k squared minus 9k minus 5 is equal to 0. So I should now be able to factorize that, hopefully. It's a non-calc paper, don't really want to do the formula. If I could, then that's going to have to be a 2k and a k at the front there. Factor pairs of 5, not many, it's just 1 and 5. So how can I put those in such a way that I get minus 9 in the middle? Well, if I put 5 there, then I'd be multiplying it with that 2k, wouldn't I? That's going to give me 10k. And then I can put the 1 here, and that's going to give me 1. And then 10k take away 1 is 9k, or minus 10 plus 1 is minus 9, isn't it? So I think it's that way around. So 2k plus 1, k minus 5 is equal to 0. So that gives me k is equal to, from the first one, if 2k plus 1 is 0, then 2k is minus 1 and k is minus 1 over 2, or k is equal to 5. Now it does say that 9k plus 7 is the smaller integer. So does that matter? I'm wondering if we can have both these solutions. So if I'm just going to check and see if one of those answers is invalid, because it would mean one term is bigger than the other, and it shouldn't be that way around. So let's say if k equals minus a half, then u1, the first term I was being given, is going to be 9 lots of minus a half plus 7. So 9 lots of minus a half, that is minus 4.5 plus 7 is going to be 2.5 then, isn't it? That's going to be 2.5. So that doesn't seem to work out. That doesn't seem to work out because k is not, or u1 is not an integer there, is it? Okay, so that doesn't work. Okay, that doesn't meet. It's a solution to the equation, but it's not a solution to the problem because u1 needs to be an integer. Okay, so it needs to be an integer, so that's not a solution. So let's try the other answer. If k is equal to 5 though, what's that then? So u1 then is going to be 9 lots of 5 plus 7. That gives me what? 45 plus 7 is 52. Just going to check u2. u2 is going to be 2 lots of 5 squared plus 3. So that's 25, 50, that is 53, so that's good, that's one more. So therefore, next term is quite easy to find. Let's just add one. So yeah, so 54. 54 is the next consecutive integer. We've got 52, then the next one was 53, so the one we're looking for is 54 then. Question 24b, x is a square number. Show that the next square number is x plus the 2 lots of root x plus 1. So if x is a square number, then the number we square to get x must be root x. Okay? And if I take root x, then add 1 to it, that's going to be the next number that I would then need to square to get the next square number. Does that make sense? So let's say I had a square number which was 16. To get the next square number, I need to root that, get 4, add 1 to it, get 5, and then square 5 to get 25, wouldn't I? So that's kind of what I've done here. So if x is a square number, I root it to get the number that I have to times by itself to give me x, add 1 to it, and then square that. That's going to give me the next square number. Okay, so now all I've got to do is multiply that out then. That's not too bad. Compared to the last one, this is a walk in the park. Okay, so just doubling that up and doing a little bit of FOIL on it. So root x times root x, well, that's just going to give you x. And then I've got root x times 1, which is root x. 1 times root x, which is root x. And 1 times 1, which is 1. And then just collecting those two root x's in the middle, I'm going to get x plus 2 root x plus 1 as required. Question 25, show that the value of 6 sine 30 plus 2 cos 30 times 4 tan 30 is an integer. Now, in order to answer this question, access these 4 marks, you must know your values of sine, cosines and tangents for the exact values that you're expected to remember for this test. Now, you need to remember the sines, cosines and tangents of the angles 0, 30, 45, 60 and 90. Now, there are various ways of doing that. Some people remember it with their fingers. There's some sort of like finger thing that you have to do it. Some people can generate the values from 2 triangles. Some people just memorize the list. There's a pattern to it. I tend to use like kind of a shrink-rayed version of the of just remembering the pattern version. So I remember a big square root symbol, and I write sine and cos next to it. Along the top I write 0, 30, 45, 60, 90, which is the angles I need to remember. Then under the big square root I write the numbers 0, 1, 2, 3 and 4, and then underneath that I would turn the numbers round, 0, 1, 2, 3, 4, and that's all divided by 2. Okay, now this is just a super handy shrink-rate version of all the different values that you need to learn, and if you can remember this structure and how to use it, you can find all the values that you need for this exam. Right, so what I need to know is sine 30, cos 30 and tan 30. So I'm just going to write those down before I do anything else. What is the sine of 30? Well, sine 30 is that one there, isn't it? It's that one which is under the square root symbol. Now, this method involves extracting that digit there, that root 1, and then that's all over 2. So the root 1 from the top part divided by 2. So sine 30 is root 1 over 2. But the square root of 1 is just 1, so that's just simply a half. So the sine of 30 is just a half. Okay? Now, the cos of 30, so it's all over 2. Okay, so the cos of 30, that's equal to, well, the cos of 30 is the cos of 30. It's that one there. It's that 3. But it's under the square root symbol, so it is root 3 over 2. It's still over 2 because it's still over that big fractiony thing. Okay? Now that doesn't simplify any more than it does, because I can't root 3. It's just root 3. And then finally tan 30. Now tan you get by dividing the sine by the cosine. So I'm going to take this one, the root 1, and divide it by this one, the root 3. Okay, so it's the yellow one over the green one. So that's how you read the values out, and if you know how to read the values out that table, that's quite an easy way of remembering all of them. Okay, and then once you've got all the values, it's just about subbing them into this this equation here then. So 6 sine 30 means 6 lots of sine 30, which is a half. So that's going to give me 6 lots of a half, and I'm going to add on 2 lots of cos 30. Well, I know that cos 30 now is root 3 over 2. So it's 2 lots of root 3 over 2. And then multiply that by 4 lots of tan 30. And I know that, well, I'm just going to simplify that down a little bit, because root 1 is just 1. That's 1 over root 3 there, isn't it? So it's 4 lots of 1 over root 3. Okay? Now, can we tidy this up? What's 6 times a half? That's 3. They cancel, so that just leaves me with plus root 3. And then the last one, I need to multiply it by 4 over root 3 then. Okay? So root 3 times 4 over root 3, I can just cancel those, can't I? I can cancel that root 3 and that root 3. It's just going to leave me with 4. So in other words, I've got 3 plus 4, and 3 plus 4 is 7. So that's my answer. The answer is 7. Now that's worth 4 marks. Actually, the maths wasn't that hard once I've extracted the values. But you need to be able to extract the values. And you can't extract the values, and you're not going to get those 4 marks. So yeah, make a revision card. Write this little thing down I've written in the red box 50 times. And then, yeah, hopefully you'll be able to recall it in the test. With that, I believe we are done.
Mr. T, he's the best.